Did you know over 70% of the world's freshwater goes to agriculture, yet most is wasted by poor irrigation? In this video, I'll show you how soil moisture works. I'm in lab, not literally in love, just in the lab. These are the materials needed. Arduino Uno R3, 9 volts battery, 5 volts relay module, jumper wires, liquid crystal I2C, breadboard, soil moisture sensor, submersible pump, 9 volts. First, let's set up the power rails. Connect the Arduino's 5 volts to the positive line of the breadboard, and connect the Arduino's ground to the negative line. This will extend 5 volts and ground across the entire breadboard. Now, let's connect the LCD with I2C. Attach SCL to A5 on the Arduino. SDA to A4. Connect VCC to the positive rail of the breadboard. And GND to the negative rail. Now, let's connect the soil moisture sensor to the Arduino board. Take the analog out pin from the sensor module and connect it to analog input A0 on the Arduino. Next, connect the GND pin to the negative rail of the breadboard. Then, connect the VCC pin to the positive rail of the breadboard. Don't forget, make sure the soil moisture sensor probe is properly plugged into the module. Now, let's connect the 5-volt relay module. First, connect the signal, or IN pin, of the relay module to digital pin 2 on the Arduino. Next, connect the GND and VCC pin of the relay to the negative and positive rail of the breadboard. Now, take the positive wire of the submersible water pump and cut it in half. Connect one end of that cut wire to the normally open, or NO terminal, on the 5-volt relay module. This allows the relay to control when power flows to the pump. Make sure your connections are secure and connect 9-volt battery. Now let's get to the exciting part, the coding. Open your Arduino IDE and get ready to write some code. This simple sketch will help us test if the soil moisture sensor is working and also allow us to read real-time moisture values from the sensor. Let's dive in. Now, go ahead and upload the code to your Arduino board. Wait a moment while it compiles and uploads. Make sure there are no errors. Once the upload is successful, click on the serial monitor in the Arduino IDE. Double-check that the baud rate is set to 9,600. As you can see, the sensor is now reading live values. When the sensor is removed from water or moist soil, the values increase. This means the soil is dry. But when you place the sensor back into moist soil or water, the values decrease. So remember, the lower the value, the more moisture is present in the soil. Now that we know how the soil moisture sensor reads values, let's finish the project by adding an LCD I2C display. If you want to learn how to use the LCD I2C module, check out my dedicated tutorial in the short section. For now, here's how the main code works in simple terms. The code continuously monitors the IR sensor and soil moisture levels. It displays the moisture readings on the serial monitor. If the soil is dry, value 400 or above, the LCD shows pump state on, activating the water pump. If the soil is moist, below 400, it displays pump state off, turning the pump off. This ensures efficient watering, keeping your plants healthy without wasting water. Now, let's upload the final code to your Arduino board. Make sure to check for any errors during compilation and debug if necessary. Once the code is successfully uploaded and running, your system will automatically monitor soil moisture and control the pump. If you found this tutorial helpful, please like this video and subscribe to the channel for more awesome projects and tutorials. Thanks for watching, and happy coding!